So now we want to look at the problems from section 10.2, which you recall involves a situation where we want to look at the difference between paired samples. So we have a number of objects, say n objects, from some random sample, where we look at them under two different treatments or two different conditions. And we compute the difference in some random variable for each object in those two conditions, and then we want to do a hypothesis test on the average of those differences. So let's look at problem 10.21, which deals with the rating of internet and TV services. And we're going to go ahead and open up this file first and see what it looks like. So let's see. So it's probably telecom. Let me just check. Yep, telecom. So we'll click on that. Okay. And I'm just going to go ahead and we're going to copy and paste that. Okay. And so these are our ratings of TV services and internets for various providers, right? And so we're going to go ahead and we want to do a hypothesis test to see if there's a difference in the mean service rating between the TV and internet services. Notice that we know that it's paired because this same object is under two conditions, two different conditions. So this is our difference D. And I'm going to go ahead and just compute these differences here. I can click and drag. And there we go. And I'm going to go ahead and I'm just going to number them. So we'll just do this and then drag this down. Okay. And it says there's 14, but that's okay. We'll just count. Okay, so now we want to go ahead and we want to compute some statistics. So you can kind of see what we need here. We need D bar, we need the standard deviation of D, and the sample size. So this test is very easy because we're not really computing a great deal. And then finally N. So I'm going to take the average of the differences. That's D bar. Okay, I'm going to take the standard deviation of the differences. That's going to be S sub capital D. And finally, my sample size is 14. Just click on it there. Okay. And now we basically have everything we need to actually work the problem. Okay, so let's go ahead and step through the hypothesis test, which is part A. So they're asking us at a significance level of 0.05, is there evidence of a difference in the mean service rating? So I want to test if the difference in if the mean service ratings are the same. Okay, that's the null. Or the way we're going to word it is we're going to test. Well, we're actually going to test if they're not equal. We're always testing the alternative. So let me state it that way. So we're testing to see if they're not equal, which is the same as saying we're testing if the difference is not equal to 0. Okay, so step 1. State your hypotheses. And we'll just kind of. Okay. So we know that H0 is going to be that mu D is equal to 0. Okay, this is the I'll do capital D. This is saying that the mean of the differences is 0. And of course the alternative is that the two averages are different, which is the same as saying that the mean of the difference is not equal to 0. Notice that our little d, if you will, okay, we always write this as, mu d is equal to some value. So here, we're going to say that this is actually equal to 0, this value here. Okay. So another way of saying this is that mu d naught is equal to 0. Okay, this is the mean under the mean of the difference under the null hypothesis. Remember, it's always this number right here. Okay. So let's go ahead and compute our test statistic. Which is very easy to compute. I'm going to go ahead, I'm going to compute the standard deviation of d bar. That's this right here. So standard deviation of d bar is just going to be equal to the standard deviation of d divided by the square root of n. And if you think of, this sounds a little confusing because, you know, we're dealing now with capital D rather than x, but you could just think of x. The standard deviation of x bar was equal to the standard deviation of x divided by the square root of n. Well, it's exactly the same thing. So it's this divided by the square root of this. Okay. And now we're ready to compute our test statistic. Because notice that our test statistic here is just d bar minus mu d, which mu d naught, it really should be mu d naught, which is 0, divided by the standard deviation of d bar. So our test statistic, is equal to d bar minus mu d naught divided by the standard deviation of d bar. Okay, and so we know this is equal to this value minus 0. That's our mu d naught. It's always a number on the right hand side divided by this. And our test statistic is huge. Okay, even for a t-distribution, that's a very large value. And let's go ahead and just round these off so it looks nice. And there we go. Okay. Okay, now we want to compute the p-value. So this is our step 3. And again, we're going to take two things in mind. The first is that we want to find the p-value for a test statistic that has a. So what we want to do is we want to compute twice the percentile of a test statistic. I'm just going to say t-score. These are all t-scores. That comes from a t-distribution having n minus 1 degrees of freedom. Okay, so we're going to say 2 times, and I'm going to be able to use just the lower percentile because my t-score is negative. If it was positive, I would have to say 1 minus t-dist, right? So I start off t-dist. There's my value. My degrees of freedom is, and I want the cumulative. And the p-score is really low. This is 7 times 10 to the minus 6th. Okay, very, very low. And let me change it. I'm going to change this. You can see how small it is. So really the rest of this problem is pretty easy because the decision rule will actually be very simple to apply. P is definitely less than alpha, right? So P, which is equal to 0 point, and we have how many zeros? 6, right? 1, 2, 3, 4, 5. Actually, we have 5, and then 7 is going to be the sixth decimal place. 0.9 is definitely less than 0.05, which is equal to alpha. So this means that we reject H0. And finally, we state our conclusion. So we say at a significance level, of 0.05, we conclude that there is a difference and the average rating between TV and internet. And that's pretty much it. Okay. For part B, they're just asking you basically to plot the differences. So we know that the differences have to be normally distributed, right, in order to use this t-test. So we want to make you can make a histogram, show that they look normally distributed, okay. It's a little hard with 14 data values though. Well, actually that's C, sorry. So B and C go together. We need to know that they're going to be normally distributed. That's B. And then C is that we would go ahead and we would actually make a plot. With 14 data points though, it's kind of hard to actually plot. Usually if it's somewhat symmetric, we usually say that's okay. But if with 14 data values, it's still hard to tell, even if it's symmetric. Okay, we want to go ahead and compute the confidence interval. So the confidence interval, so for parts B and C, we know how to do that. Okay, so I want to compute the confidence interval. So the first thing I'm going to do is I'm going to compute the margin of error. I always need that. That's equal to the critical value times the standard deviation of d bar. It's always the standard deviation of our estimator. Okay, how do we find the critical value? Well, first we need the confidence. Remember, we're doing a 95% confidence interval for mu d. So the first thing I need is the confidence, which is 0.95. And then I need alpha, which is going to be 1 minus the confidence. And so now what I want to do is I want to find the critical value. And so I'm going to be finding the value that corresponds to the alpha over 2 percentile for the t-distribution with n minus 1 degrees of freedom. Okay, so my critical value then is going to be equal to t dot inv. I divide alpha by 2, and my degrees of freedom is going to be 13, but I'm going to punch it in like that. Okay, and again, it's going to be a negative value. Okay, standard deviation of x bar we already figured out, right? There's no work to do there. We actually did that in the hypothesis test. So now we know the margin of error. It's just going to be equal to, I'm going to have to take the absolute value because that's going to be negative, times, and the standard deviation of d bar I got way up here. And that's my margin of error. So now I'm ready for the confidence interval. I'm going to get the lower endpoint first, which is going to be equal to d bar minus the margin of error. So this is equal to, and d bar is way up here, minus the margin of error. Okay. And of course the upper is just plus. So I'm just going to cut and paste this formula. Notice when you hit enter, it automatically goes to the next line. And I want to round these off because this is just too many decimal places to look at. Here we go. Okay, and now I'm ready to get the confidence interval right. So I know the 95% confidence interval for the average of the differences is equal to, and it goes from minus 4.46 to minus 2.4. Notice again, just like before, that we rejected the null hypothesis when mu d naught was equal to 0, which means that mu d naught equal to 0 cannot be in the confidence interval, and it's not. So that's always a good check you should look at. And that's pretty much all there is for these problems from section 10.2.